be doing today. Mainly, we'll be answering your questions, such as what is Robomaster Club? What do we do? How do you guys join? And also, the very important question of how will this look on your resume? How do you guys join? And also, the very important question of how will this look on your resume? Because I know that's very important. Starting off, what is Robomaster? The way that a lot of people tend to put it, and myself included, is we are the intersection of three things, which would be robotics, AI, and also esports. As a club, we span all three of these areas in many different ways, which you guys will see in just a second. And as put by The Verge back in 2016, the Robomaster competition is the world's biggest, most complex, and completely over-the-top student robotics competition, which I think is pretty true. So here's gonna just be a brief video of how the competition works. So for those of you who are not very familiar with the way the club works, is we design and build robots that compete in 2 competitions per year. One of them we actually host here at Purdue, which we'll cover later. And another competition is international, and it's hosted at some college around the US. This video is gonna be for the national competition, which will happen every summer.
Welcome to Robomaster 2021 University League competition. There are 3 different robots on each team: Hero, Standard, and Sentry. Teams must begin from their starting zone. With each robot operating in first-person view, teams navigate a rune-filled battlefield, find and launch projectiles at the opponent until they are eliminated. The robots are equipped with an armor system that detects projectile data, resulting in lowered health points when triggered. Robots are destroyed if their health points reach 0. After a period of cooldown time, the destroyed robot will resurge and gain a protective shell for 10 seconds. As the only fully automated robot on the battlefield, the Sentry can detect enemies' defense capabilities and shoot them. If the Sentry is destroyed, then the team it belongs to loses its first line of defense. The team that destroys the enemy's base first is the winner. If the 5 minutes limit of the match runs out and both teams still have their bases intact, the team with the highest total HP wins.
Okay, so that is a brief introduction to the competition as a whole. Okay, so that is a brief introduction into the competition as a whole. And there are a couple key distinctions here. The competition does stay roughly the same every year, but every now and then the organizing committee will introduce some changes into the competition. So for example, the robot that you saw that was on the rail is actually now a fully autonomous ground robot, which we have over to the side here. So although the competition as a whole tends to keep the same rule set, there are iterations usually every year. So as covered in the video, there are 3 unique robots per team. One of them is a standard robot, which is driven manually and it launches little rubber projectiles. There's also the Hero robot, which is also driven manually, and it can launch basically golf balls. And finally, there's the Sentry, which I just pointed out over there, and that robot is fully autonomous, meaning it is capable of navigating around the arena by itself, and we're also working on and improving upon an automatic aiming system. So it's able to identify other robots autonomously and launch projectiles at it by itself. And as I noted, this competition is hosted annually in late June or early July by a North American university. And on the right, you can see just a number of teams. Usually, I think there are like 20 teams competing, roughly. So, and the competition tends to grow year by year as well. And there are also some international teams, as you can see on the right, and there are many national teams on the left here. And there is also a international competition in China as well, which was the source for the national competition here. So we have some of those teams listed on the right as well. And here's another clip from the competition this past summer, actually, from CU Boulder, just to show you like a first-person view of what the competition can be like. So that's kind of like a shorter clip, but that was demonstrating that robot's ability to automatically aim and also drive around and eliminate the other robot. Sorry about that. Okay, so before we actually get into what we've done as a club, I'd like you to meet our faculty advisors. We have 5 of them, and they're all very wonderful. And we have Dr. Fong in the audience over here. He's a professor here at Purdue, and he does work with large-scale optimization. And then we have 4 other faculty advisors. I don't believe any other ones have been able to join us today, but here they are, and they all do research in some areas regarding computational imaging or machine learning, legged automation, mechatronics, robotics, and other areas such as that. So we're very lucky to have them, and they help us out a ton. So if you see them around, then definitely say hi. Professor Fong, if you'd like to come up and say anything before we begin, you're very welcome to.
Yeah, I'm very glad to be part of the team, and so I'm very different from a lot of the professors. I'm actually I'm actually spent almost 30 years in industry. The reason I came to Purdue 3 years ago is because my daughter also came to Purdue. My younger one goes to IU for business school. So I'm actually in charge of the professional master program at School of Industrial Engineering, but I work with all industry executives. So I have a meeting with Apple, going to Caterpillar, GE, you name it, like Eaton, American Airlines. So I work with a lot of industry, and so I used to do a lot of research in robotics and when I was Caterpillar, GE. But the key thing is if anyone needs help on like understanding the industry, the market, and also understanding what leadership looking for engineers, the smart people from Purdue, let me know if I can help. Okay? All right. Thank you.
So now let's get into what we actually have done as a team and what we've accomplished. So starting off, here's a bunch of photos from past years. And this shows like all of our members doing various things. The top left image is actually from our competition this past summer, and so is the bottom middle image. And as a team, we definitely all like to work together, and I think we work very well. So if you're looking for a team environment that's supportive and also very innovative, then you definitely found the right place, and I'll prove this to you later on. So one thing that I mentioned a little bit ago is that there are 2 competitions, and one of them is hosted at Purdue. We call this the Midwest Conference, and we host it every year in March. And this is a photo of this past year's Midwest Conference. And it is very well attended. We have somewhere between like 4 or 5 other universities in the US who come by, and they all have a great time. And we basically use it as a platform for them to come by, socialize, and test their robots before the actual competition in the summer. And you can see our poster on the right, and another photo from the competition itself at the bottom middle. And we actually construct our own field, and we do all of the organization and logistics ourselves. And here's a video clip from the Midwest competition that we host. Okay, and then regarding this past summer's competition, we actually placed 5th, which I'm very happy to say. And this is now our 3rd year in a row of placing in the top 5. So our team does very well, and I'm very happy to see our continued progress and also our continued strength. And this is a photo of a team who went to Colorado this summer to actually compete. Here's our current robot fleet. So what actually does our club do? Here's our current robot fleet, and we have 3 of the robots here actually. The one on the top left is here. It is the Sentry robot, which is the fully autonomous robot. We have the wheel-legged robot, which is over there, and it's capable of balancing on 2 wheels and also raising up its legs to stand. We have the Hero robot, which is currently in development, and that's one that launches golf balls. We have the Swerve Standard, which is up here. Yes. And that robot is a standard robot that uses swerve drive. And we also have a prior iteration of our balancing robot.
Hi everyone, thank you Tom. Hello everyone, I'm the project manager. My name is Jason. Hi everyone, thank you Tom. Hello everyone, I'm the project manager. My name is Jason, and I'll be talking about our semester plans as well as I'll talk about a bit about all the before everyone dive into the videos. So I believe everyone should have already seen our amazing robot over here, and we have our amazing 6 sub-teams. Not only technical teams, but as you can see on the bottom right, we have amazing business teams who's in charge of including hosting this event and hosting the March conference, as you can see as Tom just introduced. And to me, this competition is the most multidisciplinary robotics competition, as you can imagine. And we include all the technical skills, including mechanical, you have to CAD things, you have to manufacturing things. For control, you have to model things, you have to write the algorithm. And for algorithm, it includes autonomy, AI. So all the hardcore technologies, you can all find it here in this club. And we also welcome everybody who has the skills in the operation or outreach, because we also need money. We also need our sponsors to support us. So we welcome everybody, basically. So what is our plan for this semester? Video about the commercial robot arm, which we will be referring to. Here I'm going to show a video about the commercial robot arm, which we will be referring to. And looks very cool. Well, I guess we won't make 3 arms. We'll make. Looks very cool. Well, I guess we won't make 3 arms. We'll make 1 arm instead, but we can definitely build some program that dance like this, definitely. So this is our first goal that we are gonna build robot arm. Not because it looks good, but it can accomplish more complex tasks, as you can imagine. Like if you want some pizza, maybe next year we will have a robot arm to deliver the pizza with you guys. Instead of we have to queue here with the robots. Okay, here's another demonstration video Okay, here's another demonstration video about this, how robust and how cool this robot arm is. They throw concrete on this robot, and it's able to tolerate this amount of, shock and forces. And they have amazing response time with the IMU controller on his hand. And this is very tough because after you get the signal from the IMU, there's gonna be some delay. And before you send the signal to the motors, there's gonna be some delay. So they did an amazing job on this. And we would definitely want to see our own robot next year. I believe all of you guys have already seen this. So the next one will be the wheel leg. I believe all of you guys have already seen this. Probably a lot of you guys come here because of the robot. And even though it's already capable of doing a lot of motions, but it will not be able to jump onto something. For example, it cannot go onto the stairs because that's discrete motions. Therefore, it needs some kind of like discrete motion, to be able to go onto the stairs. So that would be our goal, and it needs more precise modeling because the current model will not. So as you can imagine, when you're standing on the ground and when you're jumping, it's definitely different. So there's going to be a lot of hard work, and we'll be definitely very interested in devoting to this project. Okay, so the next one, autonomous. Why autonomous? Okay, so the next one, autonomous. Autonomous. Why autonomous? Because it gives you more possibilities. And as you can see in this video, it's going to be very easy. Try to follow the light bars, which is going to be these things. So the projectors are actually going to lens on these pressure detectors, which is a very important component of the competition. And try to keep an eye on the light bars. See if you can aim. Just imagine you use a mouse to keep an eye on it.
It's not working.
Apologies for lighting, but as you can see, it's very hard for human eyes to track the light bars. And this is a first-person view of a Sentry robot, which is a fully autonomous one. It fully autonomously navigates around the wheel, and it aims at the armpits I just showed. So it's very important to have a fast and reliable algorithm that allows you to lock on your opponent before your opponent, when they're using their human eyes, to lock on your own arm plates. So that could that's the current plan for this semester, but we welcome all the ideas. So if you have any thoughts, we can always talk about it. You can talk about it with your software leads. And I'll hand the mic to Ruo Yi, who's the mechanical lead, to talk about the mechanical stuff.
I was always do that. Oh my god.
Hello guys, my name is
1 second. I don't know why it keeps doing that.
Hello guys, my name is Roy Yi. I'm the mechanical team lead, senior in mechanical engineering. As you can see on the screen, mechanical team do the skeleton of the robot. Like a powerful robot it strongly rely on a solid and reliable mechanical structure.
Use this. Yeah.
So here are the robots we built in the recent 3 years. If I label it as 1, 2, 3, 4, 5, 6, the first one, second one, fourth one, and sixth one are what we call standard robots. Basically, there are 3 types of robots you will design in the cloud. Basically, mostly they are standard robots, hero robot, and sentry robots. Sentry are fully autonomous. Hero shoot a golf ball, and standard shoot a little projectiles. This is the golf ball. This is the golf ball. So 4 of them are standards. The third one is the fully autonomous sentry, and the 5th one is the hero. What we do is basically a cycle of designing, like starting from CAD, starting from ideas, and then go manufacturing. After we're getting the parts, we do the assembly, perform a test. Then if there are something we can improve, we go back to the design step. And it's always a cycle. For a mature robot, which can be sent to the competition, we usually need at least 1 to 2 versions of applications. To be more detailed, these are some of the. Okay, never mind. To be more detailed, there's going to be many components we need to design for every of the certain robots. For example, like suspension system on the picture on the top. 4-bar linkages, some calculations at the bottom. Launching mechanism is the one that doesn't show up. Overall structure stress calculation gear set, which is being used to the hero design. It's a feeding system of the hero. Also, we do some of the manufacturing and fabrication related stuff. For example, we mostly use aluminum parts, fiberglass, and carbon fiber materials, also like 3D printing materials for building up the robots. So we need to get familiar with 3D printing, get familiar with like engineering drawing, which is necessary for manufacturing. This is our plan for the 2024 to 2025 year. So as the other members mentioned before, like Jason and Tom mentioned before, we are doing some like robotics arms design. So the first goal of us is to helping the other teams to build up like robotics arms they need to like testing. And the second goal is to improve the current wheel-like robots and the swerve drive robots because they are still going to be sent to next year's competition. And the third goal is we are going to build a new Omni-Wheel Sentry and a new Omni-Wheel Hero. That's the two robots we are going to like design starting from zero. There's gonna be more tasks to finish within the year. We'll see in the future. There are something about field fabrication because we house Midwest Conference every spring. So we also have a sub-team of mechanical team, which is field fabrication team. Would you like to talk about it? Andy's gonna talk about it.
Hello, I'm Andy. I'm technically the operations lead for the business team, but previous years, field fabrication kind of fell into business because we were the ones who were organizing the Midwest Conference. But I think it's better this year that we put the field fabrication team under mechanical team because that's where most of the people are doing padding design and manufacturing. So as part of the field fabrication team, you'll be working in Fusion 360 because that works the best with the manufacturing tools in Bechtel Innovation Design Center. If you haven't been there, please go check it out. It's a really cool place. It's a lot of machinery. You can sign up for projects there and do your own projects, make cool things. They got like 3D printers, CNC machines. I think they also have a water jet. They've got like painting rooms, fully enclosed fume hoods, things like that. And so at there, the IBC, we manufactured our 1v1 field, as you can see over there, for the Midwest Conference. So basically just CADing it, a bunch of wood parts, we cut all the wood parts, we nailed it together, and yeah. And so if you're interested in helping us build these field pieces, which might not just be repairing the 1v1 field, it could be some of the other competition pieces that we would use for testing robots, like a moving armor plate that's placed at a certain height for the autonomous systems over there to test against. Or we would build like base structure in 3v3 competition, where I have an armor plate that's just stationary there, and then we build a frame for that, and then manufacture it at the Innovation Design Center. So if you are interested, definitely talk to me, or Grant, as he's the current field fabrication lead, but he unfortunately could not be here today because Purdue flew this. Yeah. Okay. So this is us, our team, manufacturing the 1v1 field. So, and setting it up in Stewart Center, because that's where we host most of our Midwest conferences. So you can see the center top image, those are the bunkers for the field. Basically, they're designed to be just sitting there and blocking the line of sight between the two starting positions where the robots will start off the game. And then the robots can basically use them as cover while they basically strafe around them and try not to get hit and start peeking from behind the bunkers to try to shoot at the other robot. And then you also see we have netting construction there because these little projectiles, they fly very fast. If you don't have netting, people will get hurt. Yeah, and there's also painting, lots of spray paint. I think we have like 15 cans of spray paint and just like handing them out to everyone, and we just all went to town on all of these field offices.
So basically, if you join a mechanical team, what you will learn includes. So basically, if you join a mechanical team, what you will learn includes CADing skills, including SolidWorks and Fusion. SolidWorks for development, Fusion for field fabrication part. Mechanical design skills, including like how to design based on motors, bearings, screws, standard parts. Also, hands-on assembling and manufacturing fabrication skills. Like maybe you need to go back to machine shop. Also, 3D printing related skills like what's the specs for certain kinds of filaments and how to make it as strong as possible. You also gonna learn some GD&T skills, which is like how to generate drawings for sending them to manufacturers and like how to communicate with manufacturers, etc. Oh, also a very important thing, how to communicate with the other sub-teams, because communication is a very important part for the guys. So here is a brief explanation of our onboarding plan this year. I'm gonna require you to design a 17mm projectile adjustable launching and bottom feeding mechanism. It sounds complicated, but there's more details gonna show in a document if you join, and also if you have no clue to do this, I'm gonna teach you. So what you will learn and practice from this onboarding project, including how to do CAD, how to do assembly, how to do manufacturer-related things, and how to do mechanical designs using some moving parts, components like bearings, motors, etc. Also, like how to source the standard parts like flange, hinge, etc. More information will be provided in the onboarding document. Then I'll hand the microphone to control group.
Can everyone hear me okay? All right, awesome. So work controls, what does controls actually mean? So in one sentence, I would say that we bring the robots to life. So we do that in two ways. So the first part is control systems. And what that looks like is things like robot locomotion, sensor fusion. We're going to be supporting the ARM project this year. How many of you guys come from FRC, FTC? Awesome. That is awesome. The experience you guys have with that will help us very much. So you might already be familiar with things like PID and LQR. Yeah? Awesome. And then also this year we'll be looking at reinforcement learning. So we might be training the leg balance or something like that. So here we've got we just got some images. So on the bottom left here, you'll see we've got MATLAB, CubeMX, and VS Code. That's kind of our tool stack that we use. So for MATLAB, we'll create like simulations and things, and then you can see above the tools, we've got kind of a graph or chart of our control system. And then on the right side, you'll see the embedded systems, which I didn't talk about. Okay, so the second part is the embedded systems. So that would be great for compies or CS majors. So that would be implementing the control systems and then handling communication protocols and just general systems integration. And currently we work in C, and we're going to be doing C++ coming soon. So then on the right side here, we'll see that's a graph of the IMU output. And then the top right picture, that's a picture of our control board. So here we've got a video of the simulation of the wheel leg robot you might have already seen in MATLAB. real quick. So yeah, we do our simulations and stuff first just to get our everything working, and then now here we'll have a demo.
Over there. Maybe you guys can see, but
Here in the bottom right, coming to the center, we've got the wheel-like robot, and I'm on here.
Aisles, so they can like see.
Go up the aisle.
Yeah, or maybe not go up, but like in the aisles. Yeah.
So now Aman will explain.
I can't believe it. I can't believe it.
I can't believe that works actually.
Careful on the way down. Should hit up the other aisle.
Oh yeah, and also it can stand, which is awesome. And a lot of you guys might be wondering, why do we even have this complicated balance robot in the first place? It's because we can, in the rules, if the robot balances, we can have only 2 armor plates. So what that looks like is, if you want to turn it to the side, we can just face the wheel towards the enemy robot, and they can't hit our armor plates, like we're invincible. So that's why we spent all that time creating that complicated system. Alright, now I'll hand it off to Aman, which is the other control lead.
Hello, everyone. So, even with our current implementation of the wheel-like robot, there's still a lot of things that we need to work on. Jason already mentioned this. One of the first things we need to do is work on the roll compensation. So, whenever the robot's going to be going around the field, the legs may not always be in the same position, but we need to be able to hold the position of the main chassis. For example, keeping it level, even if it's on a slope incline, or alternatively, we may intentionally want to have it roll in order to take tighter turns when it's going around the field very quickly. We see some example here where we're lifting one of the legs, but we're keeping the main chassis stable. Another key feature we need to work on is being able to compensate for the slip on the wheel. So when our robot is moving around the field, it's going to be going over all sorts of obstacles and all the loose projectiles left around the field, meaning that our wheels are going to slip a lot. And we need to be able to not only compensate for this by keeping the robot stable, but also be able to have appropriate sensor models and sensor fusion, even with the accelerometer data and the acceleration data of the wheels, in order to maintain proper odometry of our robot. Finally, as we mentioned before, we want to work on having the robot be able to jump, which is the video on the left. And another key feature is that even if it's in like a non-inertial reference frame, for example, standing on a moving car, we want to be able to not only keep it stable, but also have it so that we can hold its position even as we move the car around.
So just a little bit about the control onboarding project. So what we've prepared for you guys is a mini robot. We'll teach you basically everything you need to know from nothing to being an active developer for our team. So what that looks like is, first we'll do an introduction to embedded software. It's okay if you guys never heard of that before. That's awesome. We'll walk you guys through it, and as always, ask questions. And then you'll work on this, the robot on the right here, and it has omni-wheels, so you'll learn about omni-wheel locomotion, and it's got a turret on it as well, so turret control, and then finally you'll just learn how all the components wire together, integrate together, things like that. All right, now I'll hand it to the algorithm team.
Okay, welcome to the algorithm team. I'm Daniel. I'm Kendall and I'm a junior in computer science. So we're the algorithm team and we make the robots think. We're basically the brains of the robots, as you can say. So what are we building? Everything we do in the algorithm team falls under one of these three main ideas. Every project we work on will fall under these. So first we have navigation, which as it says, it's just the autonomous robot. Like we have our Sentry robot, that's the autonomous robot. It automatically navigates and like it knows where to go itself. We got auto aiming, which again, as it says, it's autonomous aiming from the robot. Right now, Sentry robot, again, it's the autonomous one, but we'll talk about this later, but we're trying to implement that in all our other robots. And the algorithm team also has hardware. We have UART, MIU, and motion capture is something that we're experimenting with right now. So what does the algorithm team cover? So these are the concepts that we cover, you can say. We got computer vision, you can read, but like it's just OpenCV, robot localization, and motion prediction. We also do software, and ROS2 is the framework that we work with. We got autonomous navigation, as I talked about before, communication protocol, ballistic calculations, and we code in C++ and Python. And we also do machine learning with number classifiers, decision theory, and TensorFlow and PyTorch, which are the libraries for C++ and Python.
Okay, so one of our big plans this year is to tune our current navigation software. So as the image shows, this is a simulation of the robot navigating around the field. So currently, our navigation works extremely well without spin-top mode enabled. However, we still have some bugs with IMU, and also there's a bug such that the robot will sometimes get lost in navigation while connecting to a referee system. So what we're going to work on is to have navigation tested with spin-top mode, and also try to increase the navigation speed and have auto-aiming enabled while the robot is navigating. And also we want to fix the IMU bug and the referee bug I mentioned before. So another big plan this year is to have auto-aiming implemented on all robots. So currently, our auto-aiming is implemented on the Sentry, and it has a pretty solid anti-spin-top implementation. So this video is a short demonstration of our Sentry auto-aiming capabilities. So what we are going to work on is to tune our color segmentation so that we could detect arm plates with greater precision, and we also have to find the correct coordinate transform for the camera to take account to the coordinate offset of the robot to the gimbal. So another video shows what we are trying to implement. And we also have other plans as well. For ballistic modeling, we are trying to improve our model for the bullets so that we could simulate the bullet trajectory with greater precision. So in practice, the robot would aim at the arm plates more precisely. And we also have to tune our common filter to make sure that our gimbal can respond fast to the moving target.
Okay, so here's our onboarding project. If you're interested in joining the Okay, so here's our onboarding project. If you're interested in joining the algorithm team, we will work on this and we will help you out, so don't worry about it. So our onboarding project is basically armor plate detection of robots. So color segmentation, as you can see, the GIF or GIF, whatever you want to call it, over there. So you will detect the colors first. As you can see, there's like red colors first, and then it just turns green. That's the armor plate. So you detect the red colors first in the video that's gonna be provided to you. And then you're gonna do contour fitting, so you're gonna find out shapes from it, and then you're basically gonna detect the armor plates with those shapes, and in the end, you're gonna return 2D points, and that's gonna be your task. Yeah, don't let this intimidate you. We will help you out. There's more information on our GitLab on our Discord.
So hi everybody, my name is Thomas, and then I'm the current electrical lead, and then here's our handsome former electrical lead, Romo. So what does electrical team actually do? So we're like the core of the body signals. We connecting everything together, and we're make sure that every circuit is combining all together, and it's all working together. As well, on top of that, we're making sure every camera, every shooting plates, and every tunnel is working properly with our tuning. And on top of that, we're also building a lot of PCB designs. So as I'm holding this one as an example, this one is called a super capacitor, and this one can boost the robot's performance a lot by using this. So we're making a lot of fancy tools with our electrical teams, and it's also very fun because we're gonna get to do a lot of hands-on work all together.
I'm also an electrical lead, and the other job we are doing is the circuit on the robot. I hope a lot of you are from engineering, and maybe some of you want to become electrical engineering. And our goal is to avoid like a VCC to like direct to ground. You don't want to that happen. Maybe you want to see some fire. I don't know. And other team probably will blame us. We are the most troubleshoot team because when the robot doesn't work, people will always think about electrical team.
Okay, so next one I'm gonna do a brief introduction of what the hell's actual supercapacitor does. So this thing is technically like a little turbocharge for our car, and then the purpose of that is to make the car goes much faster with this. And on the left is the access capacitors. It's like the car battery that we're gonna have, and on the right is the main control panel, and it's gonna tell us when the capacitor is going to charge and discharge. So here we have two demonstration of cars. The cars on top is the one without supercapacitor. So you can see as we move along, it's moves super slow, right? But if we have this capacitor, look what happened. Boom! Exactly. So it's just like zooming. Yeah. So as we build this, it will make our like invincible because we're just zooming everywhere and no one can actually hit us. We can put it on top of our battery robot and make them turn sideways. So we're like 100% going to prove now. So this one's a little easier models of our. This one's a little easier models of our PCB design. This one's called DC-DC buck converter, and then it's also made by our former electrical lead as well. And then the purpose of this is to convert our very high voltage from our power supply and all the way down to 5 volts. And then we can use this to like charge some batteries or do some very fancy cool stuff. And also, if you're interested in soldering, I can teach you guys how to solder this as well. And you can save like $100 by not going send this to a factory or doing a lot of complicated work. You can just do it in your lab for one day.
Okay, here is our onboarding project. I don't think most of you may not familiar with the PCB design. We will start with a step by step to teach you guys how to design your own PCB and test it. And that's like one of the most important chip in our robot is L29A, which will drive the motors around. Cool.
Hi, my name is Megan. I'm the outreach lead for Robomasters. We're going to talk a little fast. Outreach lead is about how our team is represented to all of you, so things like websites, Instagram, but then it's also a lot of sponsor things. So we have a bunch of really wonderful sponsors. If somebody wants to show the back of the deck.
We have time, by the way. We have more time.
We have more time?
Yes.
Oh, wonderful. Okay. The outreach team works a lot with getting all of our sponsors in at the beginning of every semester. We've been going to IR the past couple of years, making sure all of our ducks are in a row with sponsor obligations and all that jazz, making sure you guys can, promote your Robomaster experience as best you can with things like resume reviews and a resume booklet that goes out to all of our sponsors, stuff like that. All of our sponsors, or our most important sponsors, also come to the Midwest Conference. They do some little presentations. You get to talk with them. It's a great chance for you to network, maybe make some internship connections, things like that. And we're just here to help you be the best that you can be. And you can totally join our sub-team if you are also on one of the development sub-teams, and you should totally do that.
So what we do stands for different things, all sorts of posters, t-shirts, logo design. We got a duck. So up here you'll see all the stuff we created for the Midwest Conference that was somewhat talked about. So as you can see, we do merchandising and poster at the top. In addition to that, yes, the duck. Resume booklet. So during the Midwest Conference, you can submit your resume and we will create a booklet that we will hand out to the sponsors.
Hello again. I'm Andy. I am a junior. Hello again. I'm Andy. I am a junior in computer science and I am the operations lead. We do business within the team. So, we handle basically all of, not all, because the president does a lot. Thanks for doing so much for this whole month. You've been planning everything, the Be Involved Fair, the Polytech Fair, I think, and then Boiler Bash, all thanks to it. So yeah. President, we basically work very closely with the president on all the club logistics and documentation and things. We basically just try to keep the club running as smoothly as possible. We go and plan all events. We try to note down, hey, what did we do well on this event? What can we do better when we're hosting the next event? We also try to keep everything organized, basically compiling all the media in a place where it's easily accessible. Where all the previous years, the work we've done, try to keep that all accessible to everyone in this current year, so we can go back and look at them and for reference instead of just starting straight from scratch. So yeah, we also very much kind of just help with business with leadership development, how to be a better lead, how to just host a good meeting, have an agenda, make sure things are going on track, make sure you're not ranting for too long and not able to get through your whole agenda, things like that. And yeah, keeping track of member directories so we can send to our sponsors, especially university. They want to know how many engineers we have for certain engineering colleges like ECE or ME, things like that. All right, events. Return indeed.
Hello, my name is Mason.
if you got some canes earlier, that's what we do at events. If you have any other like recommendations in the future, bring them up. So in events, in events, what we do is organize our activities for events, our space reservation, where we're going to go. And two of our upcoming events are the set sail meeting and the October Outlook. So, yeah, if you have anything else you want to bring up for future events, tell me.
So events, media, operation, and outreach all kind of meet together. So if you're interested in joining the business team in any of those aspects, we all meet at the same time, which is going to be on Saturday mornings at 11 this semester still in Kroc. So near all of you freshmen and sophomores. And if you're interested in joining us, we're going to have you complete 2 of our onboarding projects. They're real nice and short, nothing big at all. Operations going to be business handbook overview. Outreach, you're either going to go to IR and talk to at least one company in terms of getting a sponsor, or do that yourself. Events, you're going to do a mock social event, and media, you're going to submit a portfolio. Again, all really simple. Just talk to us. No big deal. Don't worry about it.
So who are we? We are Boilerbots, and we very much hope that you guys are able to join us. We are definitely looking for people in all of our sub-teams. I believe that all of our leads here are extremely talented, and they will bring you up from whatever knowledge you're currently at, however much you want to participate, and they'll bring you up to be not only a great engineer, but also foster you in terms of leadership, and also prepare you for your future career or any things of that nature. So, how are you able to join us? We had all of our sub-teams talk about their onboarding plans already, but just to outline the process in a bit more detail, this is all of you at the left, a new member, so thank you much for coming by, and we're very happy to have you. But now that you're a new member, you'll be able to start your sub-team project. And as described, these are beginner level, and they're designed to take only a few hours, and you can work independently on your sub-team onboarding project. And once you've completed this, you'll be fostered into our apprenticeship program. And this is basically when you'll be mentored by our team leads, and they'll basically assign you like a project that is directly related to a robot. So you'll be either working directly on the robot itself or working on a project that will end up on the robot. So you can get hands-on experience and really get your skills up. And these will take a bit longer, roughly a month or 2. And the top goal here, along with getting you up to speed and getting you some experience, is just having fun. I personally think it's a lot of fun to work on the robots and see what you're able to do with them, and I hope everybody up here would also agree with me. And our goal is that you would also feel the same way. And upon completing your apprenticeship projects, you'll be a core member of our development team. And just as like a general mention, we'll begin onboarding at our meeting next week, which we call the set sail meeting. So you can feel free to check out the projects, but we will not be officially starting them until next week, and I'll have a bit more details on this in a second. And upon completing your apprenticeship program, you'll be able to get one of our free core member jerseys, and almost everyone up here is wearing them. I think they're very stylish, and I know you all agree as well. So I know that's everyone's main reason for coming here and for doing this club, just because you want the shirt. So don't have to hide that. So what are the exact benefits of joining this club? The first one that I think is maybe the most significant is that you'll gain a unique personal experience that you will not regret. Me personally, I joined this team like 3 years ago, and I actually had no experience doing any sort of robotics. I didn't do FRC, I didn't do FTC, VEX, anything like that. But I ended up joining the team basically on a whim, and that actually turned out to be one of the best choices that I've made in college so far. So if I can give you guys one piece of advice, it's to take opportunities that you're given, and I think this is an opportunity for all of you, not only to meet new people, not only to hone your skills, but just to have fun as well. So I really hope you all join us and stick around especially. And I also think that this club is an avenue for a lot of personal development and also technical knowledge. You guys have definitely seen all the technical aspects that we present for the club, but along with this, there's a lot of personal development. And I think this comes from the fact that whenever you push yourself to try something new, whether it be joining a club, or pushing yourself in a project within the club, I believe that almost every single time without fail, you'll develop yourself in some way. And then another thing is you'll be able to meet people with similar enthusiasm and also make new friends. Everyone here in the club is very enthusiastic, they're hardworking, they're great people, and we plan on having numerous social events this year, which we're in the process of planning. So you'll be able to meet fellow engineers or fellow classmates or just people who have similar interests as you. We also have a lot of opportunities for research and internship experiences as well. With all of the cutting edge technology and things that we work on within this club, that is prime knowledge that you'll be able to apply for research, whether it be conducting research in the club or using experiences that you gain for doing research academically outside of the club. And just by joining a club like this and gaining hands-on experience, you'll look much better for internship applications, job applications, and of course, definitely put us on your resume. And the last thing is you'll be able to play some robot laser tag and robot paintball, which is super fun. Very enjoyable. So for some commonly asked questions, is there an application process? No, really the only thing is onboarding. Do you require prior experience to join the team? No. Again, that is the purpose of onboarding. It'll bring you up from whatever skill level you currently have to being a core member of the team. Can you join multiple sub-teams? Yes, this is actually very common. A split that I see very commonly is control and algorithm, but you're free to join really any combination of teams as long as you get through their onboarding. What is the time commitment? This really depends on your status. I like to recommend that whatever you can put in, you should put in. But I'll be covering the exact meeting times and stuff like this later on, but we do not enforce a set amount of time that you have to put into the club per week. When and where do we meet? We meet Saturday afternoons at Kroc, and then we go to our workspace from here. And here is our meeting schedule for this year. So we already mentioned that business team, which is actually misspelled, is going to be at 11 a.m., and that'll be on Saturdays. And then at 1 p.m., or roughly about 1 p.m., we're going to have our general club meeting, which is basically where all the sub-teams come by, we meet up as a club, and we talk about progress, issues, and goals that we have. And then from then on, starting at around 2 p.m., we're going to go to our workspace, and we'll be able to work on the robots and continue all of our development there. And as I mentioned, we have our set sail meeting, which is going to be next Thursday at 7:30 p.m. in Armstrong 1010. So now that you've come to the call out, the set sail meeting is basically where we're going to kick off the season. So we're going to do basically a recap of what we've done here for people who couldn't attend. But then we're also going to kick off onboarding and get you guys working and involved in the club. So definitely note that down and make sure to attend because it is very important if you would like to join the team. And we have two other checkpoint meetings basically. One of them is the October Outlook, which is where we kind of wrap up any progress that we've made in the past couple months, or at least summarize the progress that we made in the last couple of months, and try to figure out our goals for the rest of the semester and the rest of the year. And then we have our final semester review, which is going to happen sometime in late November, which will involve going through all the things you guys have put towards the club and also planning out our spring semester. So next steps, again, thank you all for coming, but definitely scan this QR code, and it'll be a form that basically just gathers your name, email, and sub-team interests, and that's just so we can better serve you guys and account for who's going to be joining which teams. And if you're not in our Discord already, you should definitely join. We have links on our Instagram, so definitely join that. And we have a welcome info channel where you should verify your email and then follow the additional instructions there. And as I mentioned, we have our set sail meeting / social event next Thursday, and we will be starting onboarding after this, so definitely come by. So as we're wrapping up, I just want to say thank you. I think we had a good turnout today, and again, I just want to say that I think joining this club is a great opportunity for all of you. I think it'll be a good opportunity for everyone to not only progress technically, but also in terms of social aspects, meeting new people. And we very much hope that you'll be able to join us and join our mission to push the boundaries of creating robotics. Thank you, Tom.
Feel free to come up here and ask questions, touch the robots, whatever. Yeah, thanks for coming.
Yeah. I actually had a question about the mechanical team.
Yeah.
So, how much experience do people usually come in with in SolidWorks or Fusion?
I have no experience when I come.
Okay, perfect.
so totally fine.
And is the workflow similar to using other other software like Inventor or Onshape?
SolidWorks is a little bit similar to Onshape.
Got it. Okay.
Have you? Which major are you?
Mechie.
Mechie. Okay. Have you learned NX?
No.
Not yet. Okay, it's totally fine. Most of the like CAD softwares are quite similar. So I will teach you if you know nothing about it.
Perfect.
Totally fine.
And how many hours usually do like the core members of the mechanical team equations?
Core member. So basically, there were only about 3 person taking charge of designing the 3 robots last year. So like, for me, designing the whole robot takes about, the first version takes about 1 week. Every day, like 5 hours per day.
Okay, so like 35 to 40 hours.
Yeah, that's like core members.
Okay.
But like other than that, I don't think you need to pay like more than 1 day per week.
Like I wouldn't like.
It depends. It's fully depending on yourself. You don't have to be like. It like take your time.
It's just like in my high school robotics, I was one of the core catters, and I really want to do that again.
Sure.
Yeah.
You can.
Well, thank you for your time.
No problem.
Oh, electrical?
So,
yeah.
we're
doing those kind of stuff. 461. I think got into this and nobody reading. Okay. Yeah, I'm really just, I did entrepreneurship before. Yeah, I did programming and you don't know what we're doing. So I'm like super excited about all this stuff. Oh yeah. I'm sure when you met, I mean mechanical.